my name is Allie Sillens, and I'm going to introduce our group's topic to you guys. So our group's topic is the oxygenation event of 400 million years ago, and around that time there was a large increase in oxygen levels in the atmosphere, which allowed for a biodiversity to increase all across the Earth. So for a little background information, Earth was formed 4,500 million years ago, and from that point up until 2,300 million years ago, the oxygen levels in the atmosphere were very minimal. There were only trace levels. It wasn't until 550 million years ago that fossil evidence first shows signs of large animal life on Earth. Remember that this is taking place with low levels of oxygen in the atmosphere. And it wasn't until 400 million years ago that we saw the largest increase in oxygen levels, which can be seen through the diversification of plants, as there was a lot more biodiversity at that time period. And as an introduction to the study that we're telling you about today, this study was done by a group of scientists from all across the world, and they used a method that was developed by Ariel Anbar. He's pictured on the right here. He was a biochemistry and chemistry professor at Arizona State University, and his method can estimate global oxygen levels in the ancient oceans.
Yeah.
Hello everyone, my name is Armand Rai, and I'm here to talk about the data. So here's what we're going to be looking at. These researchers were looking at this compound called molybdenum, we'll call it MO, in black shales. Now black shales are these rocks that are deposited in the sediment at the bottom of the oceans. Why they're important? They're important because when they're deposited, fractionation occurs, meaning it's spread out and absorbed into the sediment. And what this leads to is greater carbon absorption, which leads to more oxygen in the atmosphere. So as you can tell already, this is going to be very important when determining the amount of oxygen in the atmosphere, or these black shales rocks. So here, this first figure shows on your x-axis we have time, and on the y-axis we have the weight. So there are 180 different black shales rocks here and their respective weights. What this graph shows us is that the weights are increasing during two periods, which is kind of like here and here. This second figure shows the ratio of MO to the total organic carbon on the y-axis, and time again on the x-axis. Now this is important because the more MO, the more carbon is deposited in the sediment, therefore the more oxygen in the atmosphere.
All right, go.
Hi, I'm Julia Mizzi, and I'll be explaining to you what all this data really means. So basically what they discovered was that there's two periods in time where there was a rise in oxygen. The first period came around 635 to 542 million years ago. And this was indicated by the evidence in the fossil record of large animals. This showed, even though levels of O2 weren't as high as they are today, this showed that animals could evolve in a low oxygen environment. The next period occurred about 400 million years ago, and this rise in oxygen came about by the rise in vascular plants. The increase in vascular plants allowed them to die off and then bury more carbon into the ground. What this did was decrease the amount of carbon in the atmosphere that would react with O2 and then increase the O2 in the atmosphere. This increase in O2 allowed more complex animals to evolve, and these animals were mainly fishes who have very high metabolisms. Okay.
My name is Jason Wong, and I'm here to talk about the conclusion. So high concentrations of MO support evidence of the two major episodes of oxygenation in history. Our data provides quantitative records on the environmental history, which is important for our future and as well as to better understand our past. Oxygen levels back then were not as high as they are now, so animal could evolve in low oxygen levels. This proves the theory that animals need high concentration of oxygen to strive, and also shows that the environment can work with the biology to sustain life on Earth. Also, this is our Works Cited page. If you would like to read further about our research, you can check out this link. And if you can take anything from our research, it's that Our research supports the theory of evolution and how life on Earth originated.